Hello, hello. Good morning, good day, good evening to everyone joining us online. Depends on which part of the world you are. Welcome to the opening of our Singapore Healthcare AI Datathon 2021. I am Dr. Feng, or you can also call me Dr. Morning. I am the organizing co-chair for this event, and I'll be your host tonight. You're right. I was dancing. That was me. That wasn't a recording. That was live. And I hope that marks or share with you the vibe of the Datathon. Datathon is supposed to be a relaxed, fun, collaborative, creative event. And as you can see, if you've been following our expo from morning until now, I changed from my shirt, jacket into my t-shirt. So I hope you do the same. If it's Friday evening for you, you can even fix your favorite drink for you. If it's morning for you, then get yourself a coffee, a tea, get to a comfortable sofa, get ready to hack. Because for all the team joining our hackathon, you're going to spend a lot of time coding and creating an algorithm, so you get yourself comfortable. Right. Moving on, some new teams joining us, Datathon, or a lot of the audience joining us online. You may wonder, like, what is a Datathon? Is it a misspelling? What's going on? Okay, Datathon is a combination of two words, data plus hackathon. Basically, it's an extension for the conventional hackathon idea when people gather together, brainstorm solutions for various challenging problems. We throw in the data and the data analytics component into it. We provide teams with the real-world clinical data, and of course, we provide computational power to let them quickly test out the feasibility and the potentials for their ideas. Well, then you may wonder, like, how did it come about, right? So, like many other exciting stories, this starts with a phase once upon a time, and it was in Boston. It happened in Boston, MIT, and in year 2014, in the winter of 2014, I still remember, in the middle of huge snowstorm. It was snow. We have so much snow, as you can see. My entire car was covered up, and the only thing I can realize that was my car is the tiny antenna on top, right? I was so grateful that when I take out my car that I was right. If it was someone's car that I take out, I probably broke down in tears. But anyway, jokes aside, exactly within that winter, we organized our first event that looks like a Datathon. And what inspired us for doing that, it was started with Professor Leo from MIT, because from our daily research, we noticed that for any successful big data or AI projects for healthcare, we require the physicians and the data scientists to come together and work closely. However, these two groups of people don't really cross paths in their daily life. Our physicians are usually very busy in the hospital taking care of patients, while computer scientists, geeks like us, we usually in our labs or in our rooms busy coding our algorithms. And therefore, we created this event as a platform to gather these two groups of people. And in 2014, even in the middle of snowstorm, we managed to gather over 100 folks that were as crazy as we are. And we put them together, like I mentioned, give them a data, a comfortable space, computational power. Of course, we throw in a lot of pizza, a lot of sodas and coffee, and then magic happens. We noticed that in such an environment, people is able to find teams that they can gel well, they can bond very well, they can work very well together, and becomes a network to collaborate and make new friends with like-minded people as well. Besides building collaborations and making friends, many of these teams after the Datathon continue move on to work as a team and produce many promising results. And here is one example. This is a paper coming out from Dr. Casey Chung, one of the winners in our 2018 Datathon in Singapore. And the year after, they continued the project in Datathon and managed to publish their work in CHESS. And up to now, they have gathered more than 50 citations on the paper already. And therefore, in 2016, we formalized the word Datathon and published a paper in Science Translational Medicine, sharing our experience. Now, coming back to this year's Datathon. This year's Datathon is our second year doing it virtually. Initially, we want to do it to be a face-to-face event like we used to do. Unfortunately, we still cannot do it this year. But still, we hope next year we can gather everyone together again and invite all our mentors and guests for all around the globe to join us in Singapore. But for this year, some blessing in disguise. Since we are having a virtual event, we managed to recruit or gather supports from more than 10 site organizers. As you can see from this slide, we have healthcare clusters, SingHealth, and national health groups from Singapore joining us. We have the West China Hospital, the 301 Hospital, Beijing Tsinghua Chang'an Hospital, Zhongnan Hospital joining us as well. We have the Chulalongkorn University from Thailand. We have the Seoul National University Hospital from South Korea. We have NTUH. We have the Tokyo Mental Dental University from Japan, ICON from Japan as well, and NZIC from Australia. And last but not least, we also have the Albert Einstein Hospital joining us all the way from Brazil. And with all this strong support, we managed to have the biggest skill ever for our Singapore Datathon. We have 80 plus team submissions and from 30 plus regions, and we'll be providing 20 plus viewer healthcare data sets. And in the final, we have selected 50 teams in our final. And all these 50 teams will be competing for in total a 20,000 Singapore dollar cash. And as you can see, we have all our top 10 teams will get some prize. And 20,000 Singapore dollar in total obviously is the largest prize we had ever. And all this won't be possible without the support from our industry sponsors. I would like to use this opportunity to thank our industry sponsors, including Huawei, Microsoft, Intel, NVIDIA, ST Engineering, ASUS, Elsevier, Red Hat, TIBCO, SenseTime, Lenovo, Neo4j, Tencent Cloud, and also our co-organizing partner, Eurofund Singapore, and Holo Medicine Association, Esri Innovate, and the academia partners, including Institute of Data Science, ISS, and N.1 Institute from NUS. And of course, the cloud sources are provided for this Datathon. All the cloud computations are generously provided and supported by AWS and Huawei Cloud. Great thanks to all of them. We should be grateful. The Datathon won't be possible without their support. And of course, now all the teams are wondering, how can we win that $20,000? Okay, here are the judging criteria. Nothing complicated. We would like to judge every team based on their clinical relevance and impact for the problem they're solving. The novelty in their method, not the complexity, right? We are not looking for the most complex neural network that you can produce. No, but how novel you solve the problem and the presentation and the results, and more importantly, their plans moving forward as a team, as we mentioned. We want to emphasize the Datathon, although we frame it as a competition, but we don't want teams to end their collaboration at the end of the Datathon. Rather, we hope the Datathon marks the beginning of their fruitful collaboration. And to help every team to win, we provide many tools to assist you. First, we created a Microsoft team environment, allowing all the teams to come in to collaborate and to discuss among yourselves. Our mentors will be having sessions and talking to you through this platform as well. All our announcement will be on this platform as well. And as you can see here, if you have any questions regarding clouds, wow, amazing, I can move and point out. There's a channel called Cloud on Inquiry. So do shoot in your questions. I see some teams have been doing that already in case you have any cloud connection problems. And then we have another channel called Problem Statements and Method Discussions. That's where you can post questions and ping our mentors. And all the teams, you have your own room where you can ad hocly start any meetings, right? So this hand, sorry, it's mirror image. I try. Okay, there's a meet button here. The moment you click the meet button, you can easily meet with all your friends. Well, a very important reminder though, to qualify to the final judging, all the teams, please submit your final presentation video as a video in MP4 format, which is no longer than 5 minutes by 5th December, 6:30 p.m. Singapore time, right? Let me repeat that again. This is very important. Please submit your final presentation video, not PowerPoint, a video in MP4 format, no longer than 5 minutes by 5th December, 6:30 Singapore time. And as you can see, on Teams, there's a channel called Final Submission. And on the files there, if you go there now, we would have already created all the folders for each team, right? So please upload the final submission to the folder of your own team. Please do not upload your videos to other teams' folder because that won't count neither. Okay, so again, remind you, please submit your video by 5th December, 6:30 Singapore time. Okay, and you won't be working alone, right? We managed to recruit a very good lineup of mentors to help you out as well. Let me move out there so that you can see the full titles of them. And our international mentors include Dr. Ian, the Chief Medical Officer from Elsevier, Professor Leo Sally, of course, from MIT, Professor Finale from Harvard, Dr. Omar, the Director from NUS-CC, a subsidiary from FDA, Professor Ji Liang from MSU, Professor Judy from Emory University. And you'll be talking to some of them tonight as well. And we have more international mentors, including Professor Chen Hao from Hong Kong UST, Dr. Gloria from Harvard, Xiao Li is an exchange PhD from MIT, and of course, last but not least, the legendary Dr. Alistair and Dr. Tom from MIT. We have a very strong line for local mentor as well, Professor Daniel Ting, the Director of AI Program from SingHealth, Professor Harriel, the Senior Consultant from the Singapore General Hospital, Professor Liu Nan from Duke NUS, and Dr. Gilbert from SingHealth as well. Okay, so I think I've speak enough, and as I promised, we will allow you to interact some with our international mentor tonight. And first up, we have Tom and Alistair joining us. If you have been using the Mimic and EISU data, then their names won't be strange to you. These two guys are real legends. They are the main creators for both the Mimic and the EISU dataset. I should stop saying how amazing they are and let them show themselves, right? Tom and Alistair, do you mind turning on your camera? Yep. Hey, hello, Tom. Hello, Alistair with the baby, I believe, yes. Yep.
Hello. Good morning from dark, cold Boston.
Early, and only half of us are happy to be here. I'm sorry to say, morning.
Oh, the baby wasn't happy.
Literally just hit her face on a table before we started.
Oh,
but otherwise, she's very excited to be here. You have to start training data scientists very young, so I'm getting her involved early.
I can tell. I can tell. So Tom, to you, yes, Tom.
Okay, yeah. Good morning from dark Boston. We're just waking up here. So yeah, I'm Tom, research scientist at MIT. Thank you for the overly kind introduction, morning. So I've been asked to give a short introduction on kind of do's and don'ts for datathons. First, I'd just like to say thanks to Dr. Morning and Dr. Niam and the rest of the team who have done an amazing job for the past few years on organizing these datathons. And thanks to all of the people that are participating. I hope that we can all be together next year, keeping my fingers crossed. So some do's and don'ts. So I think the first thing is, as with most things in life, diversity is good. So, make sure someone in your team knows about clinical care, about data extraction, about data analysis, stats, machine learning, how to communicate all this together at the end. I think there's a lot there. It's difficult to end up with kind of good expertise in all those areas in a team, but you have the excellent mentors that Dr. Morning has introduced. We're all around, we want to help. So, please make use of all of the expertise that you have across the hundreds of people that are going to be, involved in this datathon. Secondly, I think datathons are primarily about teamwork. So they're about us learning how to speak each other's languages. We speak to statisticians, you speak to data scientists, you speak to clinicians, and it turns out we all use the same words or use different words for the same thing. So learn to speak the same language. Find out why your teammates are here. So I think we all join Datathons for different reasons, and each time I join a Datathon, I'm there with different motivations. Are we there to answer an interesting clinical question? Are we there just to learn a new technical concept? Maybe we're learning some SQL. We want to learn how to extract code from a database. Maybe we just want to get experience giving presentations. Maybe we want to publish a paper to further our career. Maybe we want to build a bunch of collaborators around the world. Some people maybe are just in it for the money. I know Singapore has some of the most generous prizes for the Datathons. So I think understanding why your teammates are here is very helpful. It helps you manage expectations. It helps you plan your projects. So 48 hours, I think we have roughly, is not long. So it's important to have a clear plan. Once you've got your team together, make your plan. What is your exact question? I think often people will say we're going to use labs to predict X, Y, and Z. You really want to be thinking more detailed than that. What exactly do you mean by labs? Are you going to use first lactate, first blood glucose? So start trying to break down your question, make it detailed, simplify it. You only have 48 hours, so the simpler the better, really. And it's better to answer, I think, a small question well than try and take on too much and make everything a big rush. So start simple and be prepared to adapt if things aren't going to plan. Often they don't. Often you start off thinking something will be easy, extracting ventilator settings or something. Stop time to ventilators. You find out it's very difficult, and you have to adapt. Also think about what you want to do after the Datathon. So you've got 48 hours, but hopefully you're going to be continuing afterwards. So think about what comes next. You can start with a simple question, and then you can go more detailed as a longer goal. Plan and allocate tasks. I think it's very common, particularly when Morning was starting and talking about doing this in, I think, 2014. We would maybe not have a full plan right at the beginning, and it would turn out that the data extraction took us much longer than expected, and the data scientists would be desperately trying to pull data out of the database. The clinicians would get bored because they didn't have anything to do because there was no data, and half of the people would go home, and it kind of it was not as effective as it could have been. So I think now we really try and parallelize. We try and work in parallel. So have a plan. We know that data extraction is going to take a full day. So make sure that everyone in your team has something to do while the data is being extracted. And keep in mind those motivators for your team. If someone is joining the Datathon because they want to learn something, give them an opportunity to learn that thing, because we want to make sure that everyone has a good time. Recycle old code. We've been doing this for a few years now. There's lots of code that is available on GitHub. There are lots of papers that have been published using these data sets. So, I highly recommend, once you've worked out what your question is, go and look on the web, do a Google, look at code repositories on GitHub, and try and see what other code people have written, because you can save yourself a lot of time if you can find code that someone else has written, and you can adapt it and improve it. You can actually contribute back to other people's repositories potentially. Lastly, we're all sharing the same goal. I think we all want to somehow improve care. So I haven't actually checked with Dr. Mornin and Dr. Niam whether they're okay with this, but I would say it's not something I've said in the past. But I think that if another team is using the same cohort as you, then why not reach out to them and say, let's develop this code together to extract the cohort, because it's going to make, both teams more efficient and ultimately try and, get us towards the goal more quickly. And I think this is what Datathons are about. They're about collaborating much more than they're about competition. So that's all from me. I'm going to hand over to Alistair and Zoe now. And I think they're going to give a brief introduction to, what's expected in your presentations and what's expected from your projects.
Yeah. So that was great covering of all the tips and tricks. And so I'll just focus here on the presentation that you're going to give, but mainly this is just so I can introduce myself, say hi to you all. Please ask me any questions you have about any of the data sets. I'll try and answer as quickly as possible as I can on Teams, but Tom and I have been working on Mimic for longer than Mimic 3 has been published. So we have a decent amount of experience, and we have a decent amount of experience with EICU and the other data sets as well. So just, I think the key thing from these presentations, if you don't take any tips and tricks, is that you can ask us any questions and that we are friendly people. So next slide, Tom. Yeah, so basically, when you're giving your presentation, I would say the number one mistake that's made is just putting in too much content. So what hopefully you'll get from these slides is that you only need really 4 or 5 slides covering your project, and that's sufficient to give us the message. So the first one is about what are you investigating. So you want to motivate us, you want to tell us, why is this actually a useful or interesting question? Why would this help people in some way? Why would this have some public benefit? Otherwise, we have no context for thinking that this question is useful. So that's always very, very important to motivate your project in some way. Second one is to actually have a sort of a solvable question. So you can't say, some good background noise, you can't say, oh, I think Tylenol helps, right? It's vague. You haven't said how it would help. You haven't said in what context it would help. It becomes a very, very difficult question to answer, and as a result, you probably won't get an answer. So you really want to take some time to create this clear and testable hypothesis, or at least a very clear project aim that is feasible with current methods. And then while there isn't really any competition for this, there's always the subtle competition to have a really catchy project title. And of course, whichever project makes the lousiest pun that makes me groan the most is definitely a winner in my heart. So next slide, Tom. Right, so that's number one. Number two is about the data that you've actually extracted. And obviously this is a core part, and this overlaps a little bit with the methodology, but we really need to understand the cohort that you are working with. So Mimic is, and EICU and all these data sets, they correspond to heterogeneous populations of critically ill patients. Some had surgery, some had trauma. And so we really want to know, okay, who are you actually looking at? Who would these results pertain to? So typically you're creating a flow chart like the one you see here of, oh, we're studying this subpopulation and making that very clear. Next slide, please. Yeah, so next up, obviously, okay, now you have a data set. We have a good reason for studying this data set. We have a clear research question. So how are you doing this? So, describe what your approach is. Don't throw up all the formulas, rederiving, logistic regression from scratch. That's clearly not going to work in a very short 5-minute presentation, but do give us a good high-level idea of, what is your analysis method and what is it capable of telling us. So we do have a mixed audience, so you don't want to just say, oh, I'm doing a propensity score and then leave it at that. Not everybody will know what a propensity score is. So you do want to give a general idea of what this method would actually allow you to accomplish. Please do not try and do 4 or 5 different methods, or if you do 4 or 5 different methods, don't try and present them in such a short presentation. We have had groups who say, oh, we did a propensity score and we did a logistic regression and we did random forest and then we did this deep neural network thing, and by the end of it you have no idea what's going on. So you do want to really focus on simplicity. Next slide. Yes, oh yes, come back. Okay, here we go. Okay, hi. Then, obviously, your results. This is some of the most important part, right? So, what did you actually see? I like to say you should have one table and one figure, right? Obviously, this is not a hard and fast rule, but you really should keep it very, very simple with your results. And you really are trying to send a clear message. You have all the time in the world after the Datathon to really nuance it, but for the Datathon, you're going to want to keep things simple so that our panelists can actually understand what you found and what are the interesting sort of leads that you've dug out in the Datathon. Next slide. And then finally, what does this tell you? You know, what do these slides tell you? What do these figures tell you? Do they tell you that your question is answered and your hypothesis was correct? Was it incorrect? And then, of course, what were your limitations? You did this in 48 hours, right? There's no way you did everything perfectly. So for example, if you are studying something like atrial fibrillation and you defined it using charted data, maybe you could have better defined it using waveforms if you are crazy and studying waveforms or something like that. Next slide. Yes, and then most important, okay, what are the next steps of your project? So we don't want you to just be done at the Datathon, go home, say that was a cool weekend, and call it a day. We really hope, like Mornan was saying, that this carries forward into some actual knowledge that's contributed to the public. So if you don't ever publish your result from this, then more than likely it will never actually enter the sort of medical knowledge base. So it's, you know, it's we're very hopeful that you are actually able to form a team that you like working with and that you carry the project forward after the Datathon. So you'll make tons of progress. There are projects which have pretty much gotten 90% the way there in Datathons, but it's so important to just carry it forward that last 10%. And then next slide, I think that's it. And that's it.
Yeah.
That's the entire presentation. So more than that, I always like to say at the end, you know, please do have fun and enjoy the event. It's meant to be a very high energy, sort of high pace at times event. All right,
Yeah, good luck, everyone. I think Singapore Datathon is the biggest and best Datathon that we're involved in, and I think, you know, the organizers, Dr. Mornan, Dr. Niam, all of the team do an amazing job at organizing this, and it's always exciting to see what comes out. So yeah, we're looking forward to working with you over the next few days.
Great. Thank you so much, Tom, and thank you, Alistair. And of course, I think the best presenter, no one is going to argue, the best presenters will be Joey in that presentation. Yeah, before moving on, let me also ping my co-chair for the event, Professor Niam, to say a few welcoming address. Yes, yes. Niam, over to you.
Hey, morning. Thanks for letting me welcome everyone. I think it's been such a long time since I've seen the two legends, Tom and Alistair. Yeah, really missing you guys. You remember previous Datathons in various countries, and we're certainly looking forward to a very large participation this time round in the Singapore Datathon. Those tips that you gave earlier, and I was listening to them very intently because, yeah, you know, in the past years when we did some of the judgings and we looked at the presentations, certainly we want to stick to the time, or you might be kicked off the stage. And in this case, you'll be zoomed out of the Zoom room, right? So just pay attention to the time. And certainly you want to have the most innovative ideas to solve healthcare's most difficult problem. And the last point really I want to bring is that, you know, Datathon is but 48 hours. The friendships that you make during the Datathon are forever. And of course, the problems that you solve, if you bring them to clinical practice, that's going to help a whole lot of people. And I think that's the spirit of Datathon. So I wish everyone good luck and Datathon on. Thank you, Morning.
Thanks a lot, Pana. Okay, so moving on, let's get back to our slides. Yes, after listening to the two gentlemen and Dr. Niam, can we have back our slides, the fancy ones? Yes. Next, we're going to welcome two beautiful and brilliant ladies. there will be Xiaoli. As I mentioned, she's now exchange PhD in MIT, and also Dr. Gloria, who's a research fellow in Harvard. Yeah, Xiaoli, over to you. Her slides, yeah, she will share with us some of her Datathon experience as well. Xiaoli, go ahead, yes.
Yes, thank you. Good evening, good morning. I'm Xiaoli, a visiting student in LCP lab. And first, a brief introduction to myself. I have participated in Datathon 10 times since 2016, 5 times in China, 3 times in Singapore, and twice in US. On the right are some photo of my team. It's worth mention that I haven't won the first prize so far, and I need to work harder. Yep. So before talking about the following content, I hope you guys can keep in mind 3 points. First, since we come here from different background, it's maybe our first time to collaborate with other fields. Don't be afraid, brave, because we are here to experience and learn. Every field has its master. Therefore, we should keep an open mind to communicate, discuss, and learn. Second, the completion of a medical project is separable from the joint efforts of doctor, data scientists, and engineering. So always remember that we are a team. Open our heart to communicate and talk, use easy to understand words. Third, it's necessary to remember that there is a time limit for competition, so the study content may be adjusted according to the results and feedback. It may also happen that the study objective need to be changed because some criteria are not suitable. Please don't get frustrated. It's very normal phenomenon. Just try and keep on. So how to be effectively? I share 4 points of my experience. First, know the study pipeline and pay attention to key time nodes. On the evening of the third, team member fully discuss the project, including research cohorts, variable, and outcome, and formulate the division of task and try to extract some data initially. Second is the most important and take the largest time is the second step, data extraction and processing. Multiple types of data such as numerical value, imaging, and tests may be involved here. Data extraction cover multiple data sets, and the extract data may be sparse and noisy. It needs to be processed and interpreted before modeling. This part of work is best complete on the fourth. And third, data analysis and module contribution. We should build some model and choose the optimal one. Better to get the internal and the external validation of the module, and better to evaluate the bias and the robustness of the module. Finally, the display of the results presents the research press and presents the results in concise table and picture as possible. Second, because the competition only have less than 2 days, it's necessary to make a reasonable plan. First, as far as possible, the definition of study cohort is clear, such as acute kidney injury. Use KDIGO definition according to the creatinine and the urine output. Second, create a group document to clear records every key step. Third, for some data is very difficult to obtain quickly. It can be considered for subsequent study. That is, data extraction and modeling method should be weighted. Fourth, communicate promptly when encountering problems such as the need for lab results in venous blood or arterial blood. Which one is right? So the 5 is powerful to units, such as sharing some common codes. or you can construct a simulate data according to the study variables for subsequent data analysis and module working. Second is communicate with your mentor in time and make the best use of resources. Mentor can provide us good suggestion based on the grasp of our research direction, such as innovation, whether the amount of data is supposed. Avoid many unnecessary tutors. In addition, it's necessary to update the research progress with mentor regularly and seek help if in time when encountering problem. Second is remember those start from the beginning, because there are a lot of data and code we can need maybe prepared by others before, so we must fully retrieve and use them effectively. Those are two links I recommend here. You can go first and to see that what has covered. The last point is the results should be intuitive and understandable. On the left is official judging criteria should be focused on how your solution may influence or improve the current healthcare practice. The method doesn't need to be very complicated, and the team plan for moving forward. On the right, I recommend some methods for everyone. First, use a concise table 1 to present the basic information of your cohort. Second, use ROC and PR curves and other metrics to present your results more comprehensively. Third, the results of subgroup analysis also recommended. Fourth, the last is results must be easy to understand by doctors, such as the use of feature ranking and presenting a sample case. Here, I list two interpretable methods that has been popular in the medical field in recent years. For more detail, you can see the link below. Next are some of my thoughts. Cross-field cooperation can produce more interesting results and progress. Even though the competition is over, we should maintain cooperation and communication with our team members and mentors. Second, the 2 days competition and the introduction of academic frontier and the practical application in the previous few days made me feel cooperation, profession, innovation in this field. It's a wonderful opportunity that promotes me quickly learn how to conduct a medical big data analysis project. Also, it's the first time hands-on experience and collaboration with colleagues of other fields. Datathon also changed the vein and method of my medical research. Finally, the most key point is to contribute to the advanced science and publish research results to let others know. Here, I show some articles published in Nature Medicine, Lancet Digital Health, Intensive Care Medicine in recent years. So I guess you may be very excited at this time and eager to try right. So hope you all have fun, be able to experience the charm of medical big data analysis and move to the forefront of the era. Thank you for listening.
Thanks a lot, Xiaoli. Yeah, next welcome Dr. Gloria, who's a research fellow from Harvard. Gloria, to you.
Yeah, I'm here. So hello everyone. It's a really pleasure to meet you through this wonderful events. Thanks for having me here. So I myself also have joined this series of events several times, and I actually love those so much. So first of all, it's a really nice chance to know what collaborative research work is like, especially with doctors, data scientists, and data engineers, because we actually have a different backgrounds and different way of thinking. it can be your good start to do networking as well. For data scientists or the engineers or a biostatistician, you can actually find great doctors who have the similar research interests as you, which isn't actually always easy to find. I also found great doctors, which I really enjoy working with them and through these events. And we also get to know how to communicate with them. That's what I did as well. So especially how to digest their thoughts, their insights, and their questions, and then process in your ways and provide the very insightful, very amazing solutions in your way. These are actually very important and also very precious things to learn. I also love this one so much. For doctors, it'll be also good to know and good to understand how the data science people actually work, the working process or the thinking process. We may actually sound like an AI sometimes, but we are not actually. So both of us, and including myself, are gonna have so much fun here, and I'm pretty sure about this one. Second of all, you can actually promote some of these studies as a project, as other mentors already mentioned, in the future and develop it as a manuscript as well. It's also good to see how other people actually think about your study, your thoughts, or your theory. It's almost like an unofficial review process and truly an amazing opportunity to learn from each other. It's not only from senior researchers or the senior research scientists in this field, but also from each other, the members who are actually sitting next to you guys, even virtually. I've also learned a lot and also enjoyed these events with learning these. And it may be even much more clear about what I also want to do in my research journey. So I also hope you all can also get the same or even much more opportunity to feel it and see it and also have this opportunity. So please have a wonderful time. Thank you.
All right, thank you. Thank you so much, Gloria, and thank you so much to Xiaoli as well. As both of them point out, yeah, many of our teams end up in publishing. So be very relevant. Can we get back to our slides to lead to our next speaker? Our coming up next speaker will be invited talk from Dr. Simana. Dr. Simana is a senior clinical and research specialist from Elsevier. I think most of the people in this room are very familiar with Elsevier, one of the top publishers covering science, engineering, and technology. They publish over 500,000 articles a year. And guess how many downloads they get a year? More than 1 billion. Can you imagine that? Getting back to our speaker, Dr. Simana. Dr. Simana is a medical doctor and a doctor in neuroscience with broad experience in clinical practice, research, and medical writing. Before joining Elsevier in 2012, she actually practiced in the emergency medicine as a physician at several places, such as the Massachusetts General Hospital and the Beth Israel Deaconess Medical Center in Boston. It is really fascinating because I came to Boston doing my postdoc at MIT at 2012 as well. As you can see, many of our speakers and the mentors tonight are either now in Boston or have been in Boston. So it won't be a surprise that we may cross paths in Longwood area along Charles River in those years. While with Elsevier, Dr. Simana uses her clinical and research expertise to provide strategy consults to organizers and individuals on how to advance in their research objective, make better use of Elsevier's solution to improve teams' research and scientific writing skills. And today, she's going to share with us the challenges and barriers to effective healthcare AI publishing. So without further ado, let's welcome Dr. Simana.
Thank you, and thank you very much for the introduction, and it's a great pleasure to be here. I was going, let me share, let me share, not okay, and let me open this. I was going to use the most, okay, now am I on mute? Can you hear me? Yes. So I was going to use the more formal background of Elsevier, but then I thought, well, we're among friends, and it's so I'm using actually this could be my background because I live right across the sea, so pretty amazing, although it's a little bit cold. But yeah, thank you for the invitation. This is great, a great topic, and I've been quite in touch with this topic because not long ago, a couple of data scientists from Elsevier asked me to evaluate a data set of clinical data. And then they asked me to participate in an article they're writing as the clinical expert. And I think this is a great way to get your science translated. That would be, and the colleagues before me have said it, you need to have, or it would be great that someone with medical expertise really joins your team so that you can translate your findings in a more efficient way to the layer audience than data science. Otherwise, it will just stay in your realm and will be very difficult for us who do not know all the terminology to understand it. So we started with Mimic 3. Yeah, I know the word and everything. And but then Mimic 4 appeared. So now we're sort of reinventing everything. And yeah, it's a whole new world for me. So thank you for this. I'm really enjoying it. So the title seems very, very, very promising, but actually writing effectively in AI or in any type of publishing is very difficult. And usually it takes more than 20 minutes to talk about it or to even have some knowledge about it. So I will just try to give some food for thought, and you can reach out, you know, if with questions. It's just an opener or an eye opener of what a little bit on AA publishing and AA writing, and the barriers, and what is the impact of when things go wrong. What is the impact in healthcare actually? So let's see how well I do, and hopefully this is useful for us. So I want to start with this citation I got from the New Yorker. It's from a doctor, and she's writing on AI, and this is a quote actually from someone else, but this is the basis of what we want. There's a whole, of course, a lot of myths and yeah, so more so myths on AI and healthcare, and oh, they're taking over and we're going to be replaced. But the fact is, if we are replaced on the tasks where we mess more, why not? You know, welcome, please replace us, because our brains and our capacities can do so much. So we don't have the possibility of saying, well, you actually you don't have cancer. We didn't see anything in your mammogram. Everything is perfect. And then 5 years after, I develop a breast cancer because nobody noticed that tiny difference that in my mammogram. You cannot go back and say, what did I do wrong? How can I perfect the system? And this is actually what you can do in a system that learns, in a machine that actually learns and feeds from those mistakes or those errors or those things that can be improved. So this is where actually data science and AI could come in, and is coming in very handy. So in fact, we're not there yet. And I started putting images, and you're not going to believe it, from the Bionic Woman. This was many years ago, but then I said, probably they don't know who she is, Jamie Summers. So, okay, I went with something more recent, but we're not there yet, but we're quite close, and we're getting closer to that reality where this is the Da Vinci robot, and this is AI diagnostics, where actually the two worlds are coming together in a very efficient way. So if we envision this as a tree, we have artificial intelligence and all its derivatives, machine learning and neural networks and so on, at the base, at the roots of it. Then there's a branch that goes into medical devices, for example, medical devices like AI, bionic arms and all interpretation. But then when you mix it, I mean, you can separate it from the EHR data or from clinical data, and you still have something very powerful because you mix it with scientific evidence. But when you mix it with data from actual patients, from the real world data, then you have a whole branching of incredible applications of of artificial intelligence, such as AI-powered voice assistants to translate natural language processing into actual notes that can help in the interpretation of data in a much more efficient way. We have also predictive analytics, and probably you'll be running many of those in this Datathon. You'll be creating a lot of predictive algorithms to support clinical decisions. Then you have the proper clinical decision support and clinical trial matching, for example. That is very important because we need to develop trials that represent our population in a more efficient or a more realistic way. All clinical trials have definite sets of populations of variables, but then if we can extrapolate that to the larger population, even better. So that's when really the power of AI and the data that we have either published or both, and clinical data becomes very powerful. In fact, so the Food and Drug Administration just published very recently in October, I think, a list of the first 340 AI or machine learning enabled medical devices. The whole list since 1997. And, you know, this is like, it looks like when you search in the internet for NUH, you know, it says harnessing deep learning to prevent blindness. It's just, you know, it makes my hair rise. It's like, it's so exciting to see something actually not iRobot, but actually something that we can use to prevent blindness in diabetics, for example, retinopathy in diabetics. And I especially like this is no human grading needed. It's like, okay, humans, get out of here. You're not doing it that right. We are going to make it better. So, but this is what we see. This is the lay audience, what they get. And it's really exciting. And of course, the second part is the relentless explosion of healthcare related data. And this is some data out there, 50 petabytes of data per year. And this was in 2019 or even before. So from lab tests, clinical notes, medical images, mostly a lot of medical images, from sensor readings, from wearables, genomics, operational data, and so on. So this is how big is a petabyte. I love images. I hate reading. Sorry. I don't like reading. I don't like a lot of words. I like understanding. So that's why I use a lot of images in my presentations. And also, how big is this becoming? Well, this is becoming bigger. That the amount of data produced from healthcare is much bigger, or is projected to be even bigger than many other industries, such as manufacturing, financial services, entertainment. So you can imagine how amazing what amazing amount of data you have in your hands that needs to be harnessed and understood. And this is even before the appearance of, COVID. COVID generated even more data, because the zillions of papers that were produced between the last 2 years, in the last 2 years, had never been seen before. So it does sound very promising. I love the way this Datathon is happening. I think we're in the right track, but there's many also challenges and dangers to what is happening, because everyone is very new to this. You might be in that surrounding all the time, but clinicians are new to this, reviewers are new to this, publishers, it's all happening too fast. So a little bit on the challenges and dangers is, of course, the enormous amount of data that is being published. So you're going to publish your work, hopefully, initially maybe in a preprint server like medRxiv or arXiv, but hopefully in journals, in index journals. And that is a lot of data. How much? Well, these are numbers from last year, but you can see how from 15 years ago, the number of publications in PubMed, indexed in PubMed, has increased by more than 6,000%. This is, nobody can tackle this. I mean, no mind can read this or even understand it. So of course, we need better ways of understanding what you produce as original papers. This is both a challenge for you, that it gets translated into clinical practice as fast as possible, if it's worth the translation into clinical practice. So which areas are the ones that have more scientific production? Pathology, radiology, not surprising, they have so many imaging. I would like to see here dermatology too, but these areas do have a lot of imaging and do have systems in the hospitals that record those images and notes. So that's why maybe dermatology is not here, because it's not just about production. Is what is that data? Where is that data being stored, and how can it be used? But then again, this is the important. There's so much production of scientific information, and also ongoing trials. So whenever you want to conduct a trial that is actually going to be used in humans, you should record it, any prediction rule, you should register it in a database of clinical trials, such as clinicaltrials.gov, because it's a way of being transparent of what you're doing, of being tracked. And then we want to see those results eventually of your studies. One of the challenges in AI is that many of the studies are retrospective use of data, such as using databases like, MIMIC and MIMIC 3 or 4. But those databases should serve to make comparison in prospective studies. Prospective studies will allow to draw better conclusions and more solid conclusions and better use of that data to create a more controlled environment to validate your data, your results. So this is just numbers on how many trials have been registered. And I did this, I pulled out these numbers in August, and now I did it again. So I just wanted to show you the difference just between September, October, November, December, 5 months. The difference in the number of clinical trials was 276, from 240 to 276. And the numbers of ones that are currently recruiting study subjects are, well, you see the numbers here. So there, the increase is amazing, and it's incremental, exponential. So this is the amount of numbers that we have in the back. But there's challenges, of course, because lay audience, such as myself or my family, my cared ones, they're news and things fall into the cracks, and you can see how the appetite to make this a real reality, just even before it has been launched or validated in any way. Well, AI tool promises faster, more accurate Alzheimer's diagnosis. Well, Alzheimer is a very, very complex disease, that multifactor, that is not easy to diagnose, and much less by something that has to be trained by experts to deliver something to compare against. So that's difficult to really, you have to really read into the small letter. AI is better at diagnosing skin cancer than your doctor. This is quite ominous. It means, well, your doctor is not good enough. So there's dangers of what you could be doing. That's why writing in an efficient way is the best way to translate your findings in a reliable way to the lay audience. So this is challenging for you too, for the end users. And there's many questions that surface all around all the time from these studies. What were the models used? So think about this when you're planning your study, that I will call it study, what you want to do now. Think about all these things, because there are questions that are going to come up by a reviewer in a journal, by the lay audience. Once you get it out there, you get your publication, there's going to be scientific community who's going to also challenge you and also ask questions. And many papers, well, all the papers that get retracted have been published before. So many papers get retracted per year. And so just be aware that data has to be transparent, that you should be able to reliably create a model that actually serves a purpose in healthcare, because this is the topic of the whole Datathon. We're not talking about I was going to say in Spanish about food industry, right? We're talking about healthcare. So the model was validated. Was it validated in a randomized control trial, randomized clinical trial? This is what I meant by prospective evaluation. It's great to have retrospective data, yes, that serves a lot of purposes, but in order to have the higher quality of evidence, you need prospective studies. So was it validated? Where did the model learn from? Who were those clinical experts against you, who you tested your model against? Were they residents? Were they fellows? Were they specialists? All these things come into play. is that data generalizable to the larger population? So if it's too restrictive, if you do a study on, white lilies, okay, but can you extrapolate it to lilies? I'm not going to say lilies, but black spots on your skin can be extrapolated to other spots on your skin, for example. What is going to happen to my data, right? And the lack definitely of regulatory pathways for medical devices, but that's happening now. You just saw the FDA approval. So that's happening, fortunately. And this is a great example of those dangers. Last year, this was a very, very important news that came out just at the start of COVID. There were two publications, very important, that launched a very high alarm on the dangers of using hydroxychloroquine in COVID. They had collected data from a huge database from a company named Surgisphere that doesn't exist anymore. Surgisphere claimed to have collected data from nearly 100,000 COVID patients. This got published very fast. They were fast tracking a lot of papers because everyone was desperate to get news on something. And the World Health Organization has started a trial on the use of hydroxychloroquine to decrease mortality. And then comes this paper that it actually creates higher mortality and cardiac events and everything. And the study was stopped. So there were consequences, real consequences in the world. So you might want to take a read at this, what went wrong. But actually what happened is the scientific community was very skeptical as to how can they get all these patients or all this data? They're not even that number of deaths in the world now. So it got into the public eye and they got retracted. So what it highlighted, these retractions that were very important from two very important journals, clinical journals, or medical journals, what happened is that it highlighted the gaps in the system, right? It's not a perfect system. Reviewers don't have, and you can see here, it's not an effective system to detect fraud because reviewers, what they have is what you give them. So transparency and ethics in AI is, as in any discipline, is the first thing that you should have into your mind. If your model doesn't work and give you or give anyone what it should, it is what it is. And even in clinical settings, I always urge publish negative results because publishing negative results avoids the use of more subjects, study subjects, or animals or people. So do publish negative results, even if they don't work. It's going to make a lot of good use for the scientific population. So definitely it brought up the problems with the current systems that we have. And immediately everyone started to put of course, stops to this or ways to prevent this. And for the researchers and scientists, what are the challenges? Well, you need to identify new and research areas. So I just saw in one of the last presentations, we don't want anything that complex. We want things that are novel. So simple and novel, that's a great combination to do something successful. How identify publications with high societal impact. So again, something that is novel and that is useful and that is feasible. So this is a rule that's called FINER, feasibility, something else, novelty. Well, there's this whole acronym that you can use, but definitely novelty, simplicity, and feasibility is a great combination. How do I find research groups? And you're going to be all supported to how to fulfill these questions that you may have, but just think about them because this is something that is actually going to bring you closer to something successful that can translate into clinical practice. How do I find the right journals? And this is not the moment to do so, but definitely Elsevier can support you in that, in finding the right journals. And I don't have any conflicts of interest in this talk, but we can support you with knowledge on how to find interesting journals to publish. So that, and we just saw in the presentation before, so it doesn't have to stay in the realm of data science, but it actually jumps into the realm of clinical practice, which makes it more visible for clinicians. And how do I present the data correctly? This is writing and communication skills. And again, this is not the part to do it, but we certainly also can support you with that in the future. Well, some mechanisms to overcome those challenges, and this is the last part of the presentation. You need to exercise critical thinking, critical appraisal, and critical writing. This is very important. It's not easy. It doesn't come intuitively to us, usually, especially those of us who have learned in the very traditional ways of the university. You learn from here, this book, this title, this authors, and it's very difficult to actually develop that part. So I'm going to give you some tips that actually apply to those who are reading, but actually those who are also writing. So when it comes to writing, ask yourself these questions. What aspects of existing clinical practice does this, if you're reading, or my system reinforce? Does it have an actual practical application? Are the sizes of the training validation tests set justified? This is going to be asked by any reviewer. How can we, if I'm reading, or if I'm writing, be sure the training data matches what I expect or I read in real life and does not contain bias? How can we, or I, be confident of the quality of the labels the system is trained on? Was the AI algorithm trained using a standard reference, or that is widely accepted in your field? The manner, in which the AI algorithm makes decisions demonstrated, where the results compare with experts in my field. Is the system applied to the same diagnostic context that it was trained in? And is it publicly available? I got all these suggestions from a great reading that is called A Short Guide for Medical Professionals in the Era for Artificial Intelligence. So even if you're a data scientist and I'm sure a very good one, it doesn't hurt to know what doctors need to understand and clinicians need to understand to be able to understand your work, and what are the gaps we have in order to for you to fix them before you publish something, so to make our lives easier and make your work citable so that we can reference you. So acquiring appraisal skills, as I said, is challenging, but there are some papers that can help you, and there are many more. I'm just citing two, this one in JAMA, how to read articles that use machine learning. So again, even if you're writing something, I suggest you take a look at this, because this is going to be asked from you by reviewers who are just training, and editors and editors-in-chief and the lay audience who are just training in the whole jargon of data science. There's another one, you have the references here, but you're going to have the presentation. A Short Guide for Medical Professionals. This is the one I just cited. Very, very cool. This guy is very smart. I love what he writes. He joins the two worlds in an easy to understand way. And there are tools to help you appraise articles when you're reading. For example, CASP, which is the Critical Appraisal Skill Program, has a lot of checklists. You can see how many there are. But at the bottom, they have one on appraisal of prediction rules, rule checklist. So what will happen if you have a paper on prediction rule, somebody will take this checklist and will take your paper and start checking out if you have fulfilled these items. So again, if you're just in the process of building your research protocol, your research idea, take a look at this checklist and make sure you have everything in place so that you're not taken by surprise when a reviewer says, oh, but you don't have this, sorry, rejected, or someone after you published says, oh, but you didn't have this, retracted. So be aware of the things that can go wrong. And finally, there's this amazing, I love Equator also. It's a great site to find guidelines of everything about publishing, about writing results. So it's called Enhancing the Quality and Transparency of Health Research. And they've started adding a lot of guidelines on AI. So we have the tripod for multivariable prediction model in diagnosis. Oh, I didn't get the other ones animated. I'm sorry, they had like 4. But anyway, Equator does have a lot of guidelines on. They have also an extension of the Spirit. Spirit is the protocol guide. It's a guide to create a protocol clinical study, a clinical trial protocol, and it made an extension called Spirit AI. So you might want to take a look at it also. I'll post it in the chat because, sorry, I didn't get to animate this part, but I'll post it in the chat, which ones you think could be useful for you. Because if you know what you're going to be asked when you publish your findings, then you know what you need to do before conducting your research. And of course, the development of policies and regulations is extremely important. This was done last year, in June this year. So the WHO issued 6 guiding principles, but a more recent one that I just saw is this one in October. The FDA published 10 guiding principles to aid development of good machine learning. I suppose I overrun the time. Do I have 2 minutes more? I cannot hear you.
Hello. Yeah, sure. Yeah, please go ahead. Yes. Yes.
Okay, I'm almost done. So I just wanted for you to read them quickly, because this is actually what you need to embed when you're thinking about healthcare and AI and data science is security practices, clinical study participants. You're going to be practicing, what you do is going to be put into practice in human beings. As I said, there are risks. There's media wanting and eager to get your inventions and to launch news as fast as possible of things that might not be fulfilled or near close to the truth. So be careful with that. This, I mean, I cannot go over this because you're the experts, but all these 10 rules, which are great, I think we should all be aware of them, because they will be also the way to a safety net for everyone to make sure that we are adhering to the good practices, good clinical practice guidelines, or good machine learning practice in this case. So this is the last citation, again from this great guy, Bertalan Mesco, is we might be able to assume that those medical professionals who use AI will replace or will replace those who don't do so, who don't use AI, because it will be an extremely useful tool for us to improve quality of care, reduce costs, of course, and be more efficient in every way. So this is the profound role you're going to have in medicine. So just have fun. Again, as all my previous colleagues have said, have fun, enjoy this Datathon, produce a lot of amazing and useful work. And when it comes to writing it, just call us. We might be able to, I know this is very geeky, but I wanted to put something robotic on at the end. But here's my LinkedIn profile. So send me a message and I can support you when it comes to having more insights into how to write efficiently and to get your work out there and get noticed. So thank you very much. I'm open to any questions you might have.
Hey, thank you. Thanks a lot, Dr. Simona.
Thank you.
Hello?
Thank you so much.
Thank you so much. Yeah, I'm also be mindful of time, so please allow me to shift the question and answer using the Zoom chat or the Q&A there. Of course, if you have any question would like to reach out to Dr. Simona, here is share her LinkedIn profile. Thanks again, Dr. Simona, for the very informative and educational talk.
Thank you.
Thanks a lot. Yep. So can we get my slides up, please? Yes. Okay. So moving on to the next segment, right? It's the last segment of tonight, and also one of the very exciting segment. We're going to have a panel discussion with some of our very famous mentors in the event. The panelists will include Dr. Ian, the Chief Medical Officer from Elsevier, Professor Leo Steady from MIT, Professor Finale from Harvard, and Dr. Omar, the Medical Director from NESTCC, and Professor Judy from Emory. Without any further ado, let's welcome all our panelists to turn on their camera and join me on this panelist. Yes, spotlight all of them, please. Thank you so much. Okay, welcome everyone for joining us. Yes, thanks. So first, probably let me go to Professor Finale first. I know that she may only spend a short period of time with us. Thanks a lot for joining us, Professor Finale. Can you hear us?
Yes, I can hear you.
Yes, this is the second time you're joining our Singapore Datathon. Unfortunately, both events has been virtual. We hope that next year we'll be able to see you here physically in Singapore.
Absolutely.
Yeah, so it's the second time joining us. What would be the most important message or tips or expectation from you for all our Datathon teams?
Oh, well, most important. That's a tough question. But one thing I'll say, just from one thing that I saw last year, and I think was mentioned a bit in the previous presentation as well, is just thinking about how you're going to validate from the beginning is a really, really important point, because there's so many interesting questions one can think of asking, and there's so many awesome methods that one can imagine using. But there is a limit to what you can validate in the data. So thinking carefully about what you can validate is an important question.
Thanks, Professor Finale. Next, let me go to Professor Leo. As I mentioned earlier, he's kind of the creator for Datathon, right? Leo, I know that you have, we need you to repeat yourself. I know that you already shared some of the opinions or suggestions for our teams in the morning expo. But again, I'll ask you the same question, right? What would be the most important suggestion to our teams after you've been through like 50 over Datathons around the globe?
Yeah, no, I'm gonna repeat what I said earlier too. What we have discovered really over the last few years is that the data that we're using to develop and validate the algorithms, there are a lot of disparities in care. There are a lot of prejudice and subjectivity. And the data scientists who are going to use this data, you have to be aware. You have to know deeply what disparities exist in the domain that you are hoping to investigate and explore. Because one thing that we don't want is for those disparities to be forever encrypted in the practice of medicine by baking them into the algorithms that you're going to be introducing into the workflow. So before you even do your exploratory data analysis, do your homework. Find out if you're working with an ICU data set, which populations have worse outcomes compared to the other populations, and what are the drivers of these disparities? Because if you don't understand that, then chances are you won't be able to predict what would be the worst scenario when they deploy the algorithm that you have. And the worst scenario would be widening the inequities that we're seeing right now. We've been seeing these inequities for the last 100 years, and don't expect that we're going to be fixing it. And as I said, the worst thing that could happen is for these inequities to be imprinted, forever encrypted in the way we deliver care.
Thanks a lot, Leo. Next, let's go to Dr. Ian, who's joined us for the first time, right? Dr. Ian, to you.
Yes, thank you very much. And it is my first time joining this event, and I'm very pleased and excited. Just a little bit of background, when I was a student, I enjoyed computer science and human biology. And interesting enough, the two are converging in tremendous ways here. So thank you for the opportunity. I would comment, as we go through the Datathon, there's going to be tremendous innovation and thinking and learning at what I call the speed of thought. And kind of to the comment made earlier on, as we're innovating and pushing the boundaries and learnings around technology and data use. As one of the physicians on the mentor panel, the proverbial question is, how would this information be relevant, useful? Obviously, we're going to learn about technology, we're going to learn about data, but then the clinical question is, how do we apply that? How can a clinician use that in a meaningful way, ultimately to improve the care process as well as the outcome? So I think that's the final sort of continuum of this process. And I hope to be able to put some thought into that. And to the point made earlier about the data and inequalities, having worked for many years on the implementation and the digital transformation side of healthcare, as we move to a digital ecosystem, that's been one of the challenges, is trying to put value in the data that's being inputted, because ultimately that data gets used in analytics, it gets used in machine learning and AI. So how that data gets inputted, the construct of that data, it becomes very important to know as an understanding. So hopefully I can add value to that, and definitely I'll be learning tremendously from this effort.
Thanks a lot, Dr. Ian, and welcome to the team. Next, let me go to Professor Judy from Emory University. Hi, how are you, Judy?
I'm good. Thanks
joining us
for
again.
inviting me again this year.
Yeah, go ahead. Yes, go ahead. Yes.
No, I said thank you for inviting me again this year.
Yep. So yeah, it's the second year joining us. What will be the most important suggestions or expectation from you to all our teams this year?
Yeah. So my specialty is radiology, and last year we had quite a lot of teams work on imaging data. So I would encourage people who are thinking about imaging data to also think about the corresponding clinical information, because some people say, I'm just going to predict pneumonia or pneumothorax. And I think one of the biggest strengths of this data set is that you can merge, clinical and imaging information. And then the second thing for any datathon, just keep documenting as you go along, because sometimes people run out of time and they've worked on all these amazing things. So identify who's going to document for your team and how, so that their presentation is evolving as you go along and you can get early feedback.
Roger that. Yeah, thanks a lot, Professor Judy. And last, definitely but not least, we have Dr. Omar. Omar, our good friend and old friend. Omar is now the medical director leading the safety surveillance effort in his organization. Omar, from that perspective, would you have some special suggestions or expectations for our teams?
I think one thing I would say, in terms of how you organize your time and how you think through the process, although we're always really impressed with the quality and innovation that comes out of such a short amount of time, I think everybody needs to have a very proper expectation that you will not be able to create a peer-reviewed quality research study in this weekend. And so, but the goal is that that's something that you follow through and can get to. So what you need to think about tactically and strategically is, what can you accomplish in this short period, and be very cognizant of the corners you're cutting for the 48 hours and have a plan for addressing them going forward, because you can't do all the quality and that you need in a 48-hour period with a group you're just forming. So I would say it's okay to not do everything needed in this 48-hour period, but you need to have a plan for it and be aware of how you will address those deficiencies going forward. So just be aware, no matter how good things look, you really can't do everything in this period, so be practical about it.
Can I just add to that? Just like, because I love that note, and maybe kind of the related note is think tactically about how you can fail fast. So as you think about what decisions you're going to leave for later, think about, okay, if this is going to work, we're going to see the signal here, and then try that one first, because what you don't want is, after this 48 hours, you think everything's going to be wonderful, and then you spend a couple months continuing the project, and there's a bunch of issues, and you eventually it doesn't pan out.
Yeah, absolutely. Yeah, thanks a lot for suggestions from Professor Finale and Omar. Well, for all our audience, right? So please feel free to type in your questions onto the chat or the Q&A. I will try to catch that as well, right? So this panel obviously is a very experienced researcher. Professor Finale, getting back to you again. We hear you talked on the interpretability of AI models, which obviously is getting to be a very popular research field. While in the setting of Datathon, consideration the limitation of time, yeah, how we suggest the team to take care of, taking care of pushing the accuracy of the model, at the same time covering potentially covering some of this perspective as well in terms of interpretability. Yeah.
Yeah, that's a great question because more interpretable methods often do take a bit longer to figure out how to train and such. So maybe for the purposes of the Datathon, I really briefly mentioned in the talk that there's kind of three places where you do validation. There's the data, and Leo kind of talked about that if there's bias in the data, you just don't know what's going on there, then you're going to make bad decisions. There's looking at the model, that's interpretability, and then there's the numbers. And maybe for purposes of Datathon, those two ends are much easier, like kind of being careful about your data, and then testing your numbers on various subgroups with random forest, logistic regressions, all of these sorts of simple models that establish the baseline, establish the headroom of like, are you doing better than practice, or how well are you doing? And then if you have something that looks promising, then I would say round two, at least in our lab, this is usually how it happens, is to try to train it with a much more interpretable model, or start looking at post hoc feature importances and these sorts of things to see whether you're picking up some real signal or whether it is some non-causal confounding signal instead. But I think that it's hard to do in 48 hours. I think you should ask all of these other questions first, and then start trying to tease apart the causal question.
Yep, fair point, fair point. And the next question I open to all the panelists, right? You guys have been mentors, judges for many Datathons. Are there things that the teams while judging, are there things that the teams that should definitely avoid while doing their presentation, or things that will really impress you guys, or separate teams from the others?
Yeah, I'll chime. Oh, sorry. Go ahead, Leo.
Go ahead.
No, go ahead, Omar. Omar's here.
Yeah, I was going to say this is. I'm probably going to steal your comment, Leo. But I know some of the things that have not gone over so well in the past are really kind of black box algorithms of purely prediction accuracy without a lot of context or really understanding of clinical application, and just saying, in the end, you get a result that says we tried to predict mortality and logistic regression had an ROC of this, and our machine learning model had an ROC of this, and therefore we're better. If that's your conclusion, then we haven't really advanced much or learned anything from the presentation or the methods. So I think Leo might surely expand on that. I know we've seen things around that, but yeah, that would be, you want to go deeper than that and more than just the ROC.
No, what I was gonna say is don't spend too much time in fleshing out the perfect study design and spend half your time listing all the variables and explaining this. You have to jump right away. You need to do your exploratory data analysis. You don't want to be blindsided halfway through. You don't have the variable that you need. And we learned so much during this course. There was a lot of projects that were looking at race, ethnicity disparities in the provision of care. And what we learned is that 20% of the patients, the race ethnicity that is given in the electronic health record is unknown. And those 20% with unknown race, they have a higher mortality. So you cannot just drop them from your analysis, because we don't know what bias you introduce by not including this unknown patient, these patients with unknown race into the modeling. So as I always tell people, you need to dive early. You need to know what your data looks like and do a lot of sanity checks. Does this make sense? Ask your clinicians, does this look normal to you? Or if so, why is it wrong? But we see people spending so much time on the whiteboard, and we don't want you to commit that mistake.
Thanks, Leo. Thanks, Leo. Yeah, Professor Finale, you have anything to chip in?
I agree. I think starting early and just this iterative development really important. And the exploratory data analysis is, like I said, I mean, that's where you find most of the issues.
I saw there's a audience. Josh Cool raised his hand. Josh, you want to, and also, Josh, do you have a question? Hello, Josh, can you hear us? Talking, okay. Probably just click. Nevertheless, yeah. The next question I have, which we mentioned many times, right? The Datathon is just the beginning of a collaboration, and we encourage all our teams to continue their collaborations and projects beyond Datathon. Yeah, again, open to all the panelists. What suggestions you have? What kind of support programs, pathways that teams may kind of learn from or tap on after the Datathon to continue the project? Any suggestions for that more important and longer journey after the Datathon? Maybe Dr. Ian? Yeah.
You know, as a physician, what I would say is seek some input and validation for the problem statement that you're trying to address. And to Dr. Omar's point, you know, for a physician, black box is not helpful, right? Because as a physician, I'm unlikely to change any of my thinking, my practice with black box insights, because I don't understand the physiology, the reason for the causality or the findings. So clarity on that and understanding and diving deeper. And some of it is clinical insights and inputs. So I think this is an example of good collaboration between the data scientists and technology folks with clinicians, and understanding that sort of closed loop learning that can take place, especially at the point of care.
Thanks. How about the rest of the panelists? Because, I mean, based on my experience, the journey after the Datathon is the longer and actually a harder part of the research, right? So any suggestions and tips for that too, and how to endure through that process until you end up in some tangible outcomes like a publication or some startups that Leo may not be a big fan of, or anything like that, yes.
I mean, the groups that managed to continue are the groups that really clicked during the Datathon. So friendships are gonna be started, and to me, that's really key, and a driver of success of the project that you launch during the Datathon. And that's very difficult to predict, really, or even to support. We just find that in some groups, they manage to enjoy each other's company, and you really see a learning environment where they are sharing their expertise and their perspectives. And of course, those groups are very easy to support. We enjoy supporting those groups. But in terms of the science behind it, it's really hard to pinpoint. It's almost like fortuitous that for some reason, a team that you were assigned to happens to be a team that is more likely to succeed. So it's almost like it's there already. It's premeditated. It's fate. So I hope that the other panelists would have a better advice than mine. But be friendly during the Datathon.
No, yeah, no, I think you're right. Like, I mean, good team dynamics is the key thing in terms of usually teams' performance. That said, I think maybe there are ways in which one can be kind of click professionally, even if you don't end up being buddies through the Datathon. And so if you are organized in what needs to happen and kind of clear-eyed, going back to this notion of failing fast, you don't continue just because you all feel like you have to continue or something like that, but you have a sense of like, here are the things that we would need to show to take, what our proof of concept was in the Datathon into a publication. And how can we be organized about these, showing these things that we need to show? How can we get mentoring to figure out how to demonstrate these required elements? Pull in the clinical expertise, pull in the computational expertise, and map that out. So I think, just thinking about that professional relationship, I don't know if that's more heartening than just saying that you got to be buddies, but I think that can be helpful.
Yeah, I mean, I'd say it's really important, the working dynamic. And I think Tom mentioned something really important, that, this is not just a competition, it's a learning experience for everybody, really, but everybody may have their own aspects that they really want to get out of this. And it's important to let people and support each other in the process and learning and being a team. And so sometimes that can be hard under the time crunch, but I think the more you are able to work well together as a team and support each other in terms of getting the most value from what each contributor brings, right? We all have our different areas of expertise, and letting them sort of contribute makes for a better functioning team. Sometimes you see teams just silo off, which can be okay for certain tasks, but you want to make sure that you have some cohesiveness as well. So.
Yeah, following this topic, right? So I'm not sure you guys have some experience in that, and we are still learning, because now, yeah, team bonding is always like Leo say, could be faith or could be some other chemistry, and especially now we are running these Datathons virtually, while teams need to interact with one another through a virtual platform. Do you guys have some experience from other virtual Datathons? How teams still manage to get some team bondings and chemistry goings, and how to effectively communicate with members may not be physically at one city or one place. Any experience that our panelists may share? Leo's face is look like, oh, that's gonna be tough.
I'm a little more optimistic. Where I've just been reading Crucial Conversations, which is this book on on communication and stuff like this. And there's many. I think that one of the important things to do early on is just find the opportunity to be authentic with each other about, what are your goals for the Datathon, where you're coming from, what your interests are. Establish some sort of norm for how you're going to talk about how you're going to be organized. Establish a norm that's like, if someone feels like we're going down a pathway that doesn't make sense, how will we respectfully bring up the fact that maybe we should switch directions and these sorts of things. And establishing this norm of open communication, open, respectful communication from the beginning, I think can be, again, maybe it's harder to make the kind of friends that you make in person, but I think it's very possible to have a very productive professional relationship, even if it's remote. If you all kind of agree that we're going to be authentic, we're going to be open, we're going to be respectful from the very beginning, which sounds easy, but is actually not, right? It takes a lot of courage. It takes a lot of bravery to be like, okay, here are things that are important to me. I really don't like how you're organizing your Google Doc or whatever it is, or your code. Could we change it up a little bit? But establishing a norm where that communication happens early will make a team more productive in future.
Great, thanks, Professor Finale. Yeah, I also noticed that we have a few more mentors joining us on Zoom. Let me try to ping them, right, at Holly. Yeah, Professor Chen Hao and Gilbert, are you guys there?
Yep.
Yeah, turning on your camera and join us.
Yes.
Yes, yeah,
Yep.
A quick introduction. Professor Chen Hao, he's a faculty in Hong Kong. Probably I should let Professor Chen introduce himself, yes.
Yeah, I think, yeah, thank you, Moni. I can't resist, jumping in. So thank you for all the organizing this actually wonderful talk and all the insightful sharing from the experts. So my name is Hao Chen. So from the Hong Kong University of Science and Technology. I'm in the CSE department. So yeah, I think I have actually both academic and industrial experience. So also actually I co-founded a startup, and now it's running well. And also now I'm a faculty member in the CSE department at HKUST. So I have been working on the medical AI in the last 8 years. So mostly actually on the medical image analysis with the artificial intelligence or deep learning actual technologies. So recently, actually, I'm more interested in the label efficient learning and interpretable learning algorithms. So yeah, so pretty much, I think, yeah.
Yeah, so Prof. Chen, yeah, so getting back to the question on some tips on the for the Datathon, right? I know that you are expert in computer visions, and so while you guys are building like various backbones or structure of convolution networks, do you see that people can still effectively collaborate and build that network together online, or you feel like that's a very personal touch thing that people should just do it themselves?
So maybe I can because the voice actually is a bit fast. So I understand your question actually clearly. So you mean actually the models regarding the public ones or the private one?
No, yeah. My question was that in computer vision, right? Often you guys need to build quite a complex convolution neural network architect. Do you feel like teams that may be formed from strangers, right? From various backgrounds and from various places, can effectively come together and build that together? Do you believe that may happen, or any tips that how teams like that may work together and build that together? Yes.
Yes, thank you. So I think so my background is more like medical actually. So medical AI. So also actually work on the computer vision sometimes. So personally, actually, I think for the medical background is excellent if you know the experts are cross-disciplinary. So with medical, doctors and also computer vision guys, and also the some engineers and scientists. So when we build a neural network, actually, I think it's not only it's the motivation is very important. How to actually to design the network, and also what kind of problem you try to solve. What's the key challenges here? So we need actually the questions from the the customers, also the users who actually will use them. This is the first, and the second, how to solve them. We needed to actually, of course, we needed to brainstorm on all these kind of technology solutions, but we needed to actually the motivation how to design them, and what's the key points there. So we need to actually have brainstorm and discuss a lot on these ideas. And then after that, when we develop the model, we needed to actually validate it. And even for the computer vision, if you wanted to deploy the models for the customers, for example, the traffic, the smart traffic solutions, and for the users, actually, how to evaluate and what's the feedback, and then you actually keep, refining it in this kind of loop. So I personally feel actually it's necessary and actually of significance to collaborate with others. Yeah, we actually, because the AI is not the, I think AI is not the ultimate goal, actually, how to solve it and the user feel happy and satisfied with the solutions, and that's the target.
Okay, thanks, Prof. Chen. Yeah, for the last 15 minutes of this panel, please allow me to invite our other mentors, Tom, Alistair, Gloria, Xiaoli, and Gilbert onto our panel as well, right? Tom, Alistair, Gloria, and Xiaoli, and Gilbert, do you mind turning on your camera as well? Yes, and thanks a lot, Professor Finale. Yeah, I know that you have to sign off. Yep.
Apologies, some issue in my camera.
Oh, no worries. Yeah, Xiaoli and Alistair. Alistair, are you still busy? Okay, no worries. Yeah,
I think Alistair is on a flight now.
All right. So yeah, we do have a question from the audience. is asking from a clinical perspective, what could be the pitfalls that our team should be mindful of when designing their projects, defining their problem statements. Yes. Yeah. Tom, Gloria, yeah, and Alistair, you may chip in as well. Yes. Alistair, I know you are trying to say something, but white noises. Okay, so yeah.
Alistair is on his way from Toronto to Boston this morning, so I think he is probably he probably is traveling.
Yep. Then Leo, yeah, want to take a step on that question?
What we don't want and what we see, I mean, this is not a criticism of the Datathon, but it's just a call to action of trying to perhaps pivot. So we don't want to see an AUC that you improve the AUC by 5% or 10%. It doesn't mean anything to clinicians, especially if we don't know what's happening behind the scenes. So, and I keep saying that accuracy should not be the sole metric, because if accuracy is the way you evaluate algorithms, then we have a problem, because the ground truth right now is not fair. Some people are getting worse care, some people have worse outcomes. So just imagine that if accuracy is the pillar of your evaluation, then we have no hope of improving what we're seeing right now in healthcare. So you have to be more creative. And as I said, I always complain when I review papers for computer science, machine learning conferences, because all they're saying is that, oh, we improve accuracy by 5% or 10%. And to me, like, well, that means that we're stuck in the world we live in, where there's so much disparities and there's so much inequities. So think about that before you make your final presentation. We don't want just better AUC curves or AUPRC. That's not what we want. I think we're failing as a community if that's all we're after.
But Leo, a follow-up question. Actually, someone was discussing that with Omar in the chat as well. So if accuracy is not the matrix to measure, then what would you recommend to be important things to report?
I mean, this is an ongoing discussion, and we could probably chat for hours on this. What we are saying really is there has to be like a fairness dashboard. Fairness couldn't be an afterthought. You shouldn't be thinking about bias at the end of after you've developed the model. The goal of the algorithm should be perhaps reduce some of the disparities that we're seeing. And we don't have the right metric right now. This is a very hot topic in machine learning for healthcare. Fairness metrics that are being proposed right now are still based on accuracy. And as I said earlier, there's some problem there if accuracy is the only way that you're assessing fairness. If you're only looking to minimize false positives and false negatives across group, that's not enough, because what's going to happen is that those marginalized groups are always going to have poorer outcomes, because you're trying to predict accuracy in the real world and the ground truth is not fair. So perhaps that this is too complicated for the Datathon. Maybe I will stick to the advice that have fun, try to make friends, so that there's a higher likelihood that you're going to continue working even after this event.
Okay. Okay. Thanks a lot for the suggestion. Yep.
Can you hear me all right now, Morning?
Yes.
Sorry, my headset.
No, go ahead. Go ahead.
Sorry for that. Yeah, I am kind of doing too much as always, but I would say the number one thing I've seen in successful teams is the ability to sort of parallel process. I'd say the teams that are the least successful are the teams where there's one person at the table kind of hacking away at SQL and another 6 people watching that person hack away at SQL. So it's really worth it to take the half an hour at the beginning and kind of see, okay, who can do the lit review, who feels most comfortable with that, who feels most comfortable doing SQL. Okay, well, this person will pair up with the sort of respiratory therapists, and they'll help get our ventilation code. Like actually thinking through how everybody can contribute at the beginning is one of the traits of the most successful teams I've seen.
Wow, actually that's a very good reminder, right? So effective team is always a team that everyone's willing to contribute, right? Regardless of what perspective that will be. Okay. Yeah. Any from other panelists? Anyone to chip in? Omar, you want to follow up? Yeah, on that as well. About the matrix, other perspective to show the contribution.
No, I mean, I think we covered quite a bit. Like I said, in Leo, I mean, I think understanding, you know, how this is contributing to practice and what to do with it, why this might be better, how to apply the model to different patients becomes more insightful than just the accuracy. And I've always been equally troubled with, you know, the fairness issue and model accuracy and performance. As someone who's done a lot with benchmarking performance, it always bothered me when people would say, well, the model's not calibrated right because the outcomes are different in this population. And it was very hard to understand conclusively how much is it because this hospital has better or worse outcomes. Is that because the model doesn't work, or is it because the care provided or something about, you know, that hospital is different? And I don't think our models really get into that, right? It's just accuracy, and it's hard to know. So it is a complex area for sure.
Yep, understand. Yeah, Xiaoli, yeah, looks like you want to share something, Xiaoli.
So maybe you can try to clear displaying the cohort, like the baseline, and do some subgroup analyze, or like if have further time, like do some actual validation in other hospital, like try tree model use mimic and test or EICU data set, and the EICU have like over 200 hospital. Maybe you can try that which hospital, teaching hospital or non-teaching hospital is better, or like maybe it's better to a large percent patients, but some small percent patient maybe not suitable. Try to study some group analyze. Maybe it's suitable for older patients or younger patients. I'm not sure. Just to do more analyze to show the results. Maybe it's useful for us to understand the performance and the results.
Thanks. Yeah, I think one more team asked a question. I think it's quite a fair question, right? Although we are emphasizing the clinical perspective and the importance of that, no doubt. But they're asking how about data-centric innovation in machine learning and data science? Are they welcome in Datathon settings?
What does that mean, data-centric innovation?
That's a good question. Chris from the audience, yeah, you want to, if you raise your hand, we may even allow you to open your mic. Chris, are you still there? Yes.
I mean, I could wager a guess that, you know, a lot of this is true that we always have the flavor of focusing on more clinically relevant / actionable questions. But there's definitely space to think about, well, how would you just analyze a data set like Mimic, like EICU, and make that process easier or better in some way, independent of a clinical question? I think that's something that there could be tons of work in, because basically we kind of figure this out as we go, and maybe there's a framework or a process or a methodology that makes that easier.
Yeah,
it's not a traditional data, but there's no shame in trying it if you have a good idea in that route.
Oh yeah, sorry. Yeah. Was I supposed to speak just now?
Yeah, Chris, go ahead. Yes, yeah, Chris.
So yeah, I'm just wondering for this hackathon, because we my team, we have some ideas, concerning innovations when it comes to health, but it's more to data-centric innovation. Like for example, introducing a new kind of data augmentation technique. We plan to showcase during the for our video. Yeah, not sure if I could reveal it now, but yeah.
Leo, how about you quickly address that? I know that you have a hard stop at 10.
Um, so what we also don't want is for teams to bring in already a 90% product and then use the Datathon just to polish it, because I think you're not taking advantage of the wealth of expertise and perspectives in the Datathon. So we would caution you about just bringing in something that you have been working on for the last year and see how you can improve that over the next 2 days. I think that is really gonna not promote the spirit of the Datathon, where there are different perspectives that are contributing to the design of the problem and the understanding of the problem.
I guess just thinking from my perspective and as a I guess an engineer's perspective, I think there are interesting things that can be done that are not what I would typically think of as a clinical question. So one thing I'm thinking about, Leo says that we don't have good measures for assessing bias in our models. I think if someone can, if your project was coming up with a new metric that emphasized or assessed bias within a model, then for me, I think that's very interesting, and I think that that's kind of moving away from what we typically see in a clinical datathon. I also think that there's a lot of value in developing tools to make it easier for people to extract data from data sets and to run models against data sets. And I also think that I would love to see more of that kind of thing in the datathons.
Yeah. Please allow me to chip in as well. Right? Teams don't have to get too pessimistic, right? I think the reminder all our mentors and judges are trying to remind everyone is, we don't want like people coming in with like ensembles of multiple complex neural network and just trying to push the needle of the AUC from 0.92 to 0.98, right, and say that we have a success, but rather really find a gap when we see either motivated by a clinical challenge or even it's a clinical problem, but we see from a more data perspective, while there's actual needs for knowledge solution for such a gap, then any novel solution for that will be appreciated. I hope that sums up everything. Any more?
Morning, I think you have to speak closer to the microphone because your audio always goes down when you're the one speaking.
sorry, my bad. My microphone is actually up there. I will try. Yeah. Okay. So any closing remarks from our panelists before we close this session?
Yeah, I just actually wanted to echo Leo said. So I think the metric, the evaluation metric is important, and the AUC or the accuracy actually are very important metrics for actually data centricity, data kind of technology solutions, but they are not only the one actually. So how to actually understand the problem further and leverage all these cross-disciplinary expertise during the collaboration, and that's also very important. And to actually close this knowledge gap and understand the challenge or the problem, most important, and to enjoy the challenge.
Thanks. Let's thank our panelists again. Thank you very much for your very fruitful suggestions. And let's zoom back to my slides and I'll just give a few more reminders for our teams, right? So I hope all of you have been enjoying that very engaging discussion. Again, a reminder that again, this is not the end, right? So you can still approach all our mentors on the Microsoft Teams as I mentioned, you can either send them a personal message or post questions on the various channels, especially the problem statement and method channels, and discuss with them. And of course, as many suggest that you should be very engaging your team members as well and work as one team. And yes, the last reminder is that please do remember to submit your presentation videos no more than 5 minutes by the 6:30 Singapore time on the PM on 5th December. And with that, we come to the end of the opening of the Datathon. Now it's about 10 p.m. Singapore time. I think it's a perfect time for you to start hacking. So yeah, do interact with us, ask questions to us on the Microsoft Teams. I hope you have been having a great night and happy hacking, everyone. I hope you can hear what I'm saying. If you can't, you can see me waving. So bye, everyone, and happy hacking. Again, great thanks to all the mentors and panelists joining us tonight. Thank you so much. See you on Microsoft Teams. Bye-bye. Happy hacking. Bye-bye.